Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of marginal distribution. So this is what uh, we're going to see in this video. And let's recap on what you have learned in chapter 2. Well, you have learned about joint probabilities and marginal probabilities. And if let's say you can't recall what are those all about, well, you can just refer to this video right here, okay, related to the idea of marginal, joint, and conditional probability. This one right here, yes, video number 7 on the playlist of theory of probability and statistics. So basically that basic ideas which you have seen are going to be carried forward here. So here when you have more than one random variable, then what you can do is you can describe them together using what we call the joint probability distribution or the joint probability density, depending on whether those random variables are discrete or continuous. And I've talked about this in the previous video where we give this notation fxy. So here is the joint probability distribution or the joint probability density. Okay, now naturally we may also be interested in breaking them apart, in breaking this joint probability, so that we can just focus on one single random variable. For example, instead of talking about this joint probability distribution or density, you might want to focus on just fx, or you might just want to focus on just fy. So this is what's marginal distribution or marginal density is all about. Okay, so to introduce the concept of marginal distribution, we're going to consider the following definition here, where this one refers to the case of discrete random variables, and this one is considering the case of continuous. Okay, now let's see, if we have x and y, they are both discrete random variables, therefore they can be described together using what is known as this mathematical notation. Basically it means the joint probability distribution. So we can describe x and y using this function here, where this function is depending on x and y together, and it is known as the joint probability distribution. Therefore, if you are interested to find the marginal distribution, so now we are interested to find the marginal distribution of x, or you might be interested to find the marginal distribution of y, then those distributions, those marginal distributions can be found using this formula given here. So basically this is, you can see this gx here is a function that depends only on x. So we are talking about breaking this joint probability distribution to its respective part, which is for this one only related to x. We have a function of gx where this function is just related to x. And we can also find the marginal distribution of y. So here we've got a function that depends only on y. And in order to find, for example, this marginal distribution of y, what you need to do is you need to sum up the joint probability distribution. So this is the joint probability distribution. You're going to sum this up across all x's. So this is summing up. Sum, so you have the sigma notation here. It represents the process of adding up or summing up the values. So you're going to sum up all the values of this one across all x's, something like that. Okay, so in order to get marginal distribution for y, you're going to sum up this value here with respect to all x's. And you can see that in order to get the marginal distribution of x, what you're going to do is you're going to sum up all the values here with respect to y. So you're going to sum all the values across all y's. Okay, don't worry too much about this mathematical notation here. You will see it more clearly when I represent an example later on. Okay, right. Now for continuous case, you can have x and y. Those are continuous random variables which can be described using this function here, and you can see that this function here depends on both x and y together, and we call this a function as the joint probability density at x and y. And then if you want to break them apart and you just want to focus on single x or single y, then we are actually interested to find the marginal distribution of x and the marginal distribution of y, which can be found using this formula given here. So for example, if you want to find the marginal distribution for x, what you need to do is you need to integrate this joint probability density with respect to y. So you're going to integrate this function, the joint probability density here, with respect to y, and these are the limits according to the y limits. Okay, and in a similar manner, if you want to find the marginal distribution for y, what you need to do is you have to integrate the joint probability density with respect to x, and here will be the limits associated with x. Now by doing this, you will see that we will get rid of all the terms related to x, and so we will have a function that depends only on y. Okay, I hope that with example later on you will see more clearly on how the formula is developed as such, and you'll be able to understand the process better when you look at the example. Okay, now in this video I'm going to just talk about the example related to the discrete case, and then perhaps in the next video we will be looking at the case for continuous random variables. Okay, right, now let's move on to the example here. This example is based on the result obtained in example 3.9. Now if you don't remember what's example 3.9 is all about, you can go back to those examples really, but let me just tell you about what is it all about. In example 3.9, we had a problem of creating the joint probability mass function or joint probability distribution for fxy, where x represents the number of aspirin and y represents the number of sedative. Okay, so we have the combination of x and y right here. This is the result that you have already seen in example 3.9. Now based on the result here, we are going to find the probability distribution of x alone, and then we're going to find the probability of marginal distribution of y alone, and the answers are already given right here, and I'm just going to show you how we can get the given answers. Okay, right, according to the formula, if you want to find the marginal distribution for x, which is gx, the formula that you should use is related to adding up the values for fxy. So fxy is the joint probability mass function, and this will be sum up with respect to y. So what does it mean really? Now it means that in your mind you should be thinking about when you talk about gx, you're thinking about what are the values that x can take. And you can see clearly from the table here, the values of x can be 0, 1, or 2. And we're going to consider that one by one. So first of all, let's consider when x is equal to 0. So when x is equal to 0, we have g 0. I'm just substituting the value of 0 into this part. So we have g0. Here we have the value of y, which is maintained at this notation, and we have f0y. Okay, and then what we're going to do is we're going to keep on changing the value of y. So accordingly, okay, so we're going to change the value of y accordingly, and you can see that the value of y has values such as 0, 1, and 2. So we're going to take turn changing the value of y according to this notation right here. So first of all, we're going to start with f0, y is equal to 1. So that's the first one. We take the lowest value, that will be easier or more systematic. Okay, so now we can see that y is equal to 0. So we're going to consider that first, and then we're going to sum up 0, and the next y that we have to consider is this one. So y is equal to 1. So that's what it means by the process given in this mathematical expression here. And then we're going to have 0, and we go to this value. Okay, so what we're doing next is we're going to consider what is f00, which is this one really. So that is 12 over 72 plus 0 and 1 is 16 over 72 plus 0 and 2 is 2 over 72. And therefore, you will see that 12, 16 is 28 plus 2 is 30. So we got the answer here is 30 over 72. So this one is equal to 30 over 72. All right. Now let's move on to the next value of x, which is 1. Okay, so now when x is equal to 1, we're going to repeat the process. What we have is we have g1, and this one is summation over all y's, f, and this is 1, y. Okay, and we're going to take turn changing the value of y accordingly, and you can do it from lowest to highest. Okay, so here what we have is f1, the first y is 0, plus f1, the second y is 1, plus f1, the last one is 2. So that's the process, and we can see that the values associated with all this joint probability distribution is 24 over 72, 12 over 72, and 0. Okay, so those are the values. So just write down all the values, and you can see that 24 plus 12, this is the result that you get, 36 over 72. Okay, now finally, for when x is the last value, x is equal to 2, therefore we have g2, this is the summation with respect to y, f2, and y. And again, we're going to do the same process where we're going to take turn changing the values of y accordingly from the lowest to the highest. So what we have is f20 plus f21 plus f22. Okay, I'm sorry, I'm running out of space here, but this is f2 and 2. Okay, so the answer here is going to be 6 over 72 plus 0 plus 0. So final answer is this value given right here. And basically that's it really. We have managed to get or to focus on just the marginal distribution of x. That means we're just interested to know what's the marginal distribution for x when x is 0, 1, and 2, and we can represent the answers using a table that looks like this. Okay, I'm going to erase the ink on this slide, and we're going to look at how you can find the probability distribution for y alone, and that is known as the marginal distribution of y. Okay, so in order to find the marginal distribution of y, again we're going to follow the same idea, which is we're just going to use function hy just to differentiate between g and h, but really it doesn't matter. If you want to use gy is also fine really, but never mind, we just stick to this notation right here. So according to the formula, if you want to find the marginal distribution of y, we have hy, and we're going to sum up the joint probability distribution, so this one, with respect to, if you want to find y, then you have to do it with respect to x. Okay, so this is the formula, and let's see what are the values of y. So you can see that the values of y can be 0, 1, and 2, and we're going to consider that accordingly. Okay, so we're going to start with what happens when y is equal to 0. So when y is equal to 0, this mathematical expression here, mathematical equation here, mathematical formula here is going to change to h0. This is with respect to x. This is f x0. And what it means right here is we are just going to keep on changing the value of x, step by step. We're going to start with the smallest x, and then we move on to the next x and the next x until we are done with all the x's. So what we have is the value of x starts from 0, and then it moves to 1 and then 2. Okay, so here what we have is f0 0 plus f1 0, you change the value of x, plus f2 0, and according to the table, f00 is this one, 12 over 72, f10 is this one, 24, and f20 is this one, 6 over 72. So this one is 36 over 72, plus 6 is 42 over 72. So this is the result that you see right here for y equals to 0. So y equals to 0, the result is 42 over 72. Now let's move on to when y, so here we're done with y equals to 0. So now let's move on to the next y. The next y is y equals to 1, and in this case this mathematical formula here is going to change to h1. This is with respect to x, fx1. Okay, and then we're going to take turn changing the values of x here, okay, from 0 to 1 and 2. Okay, so what we have is f01 plus f11 plus f21. Okay, and the values associated with that are 16 over 72 for this one, 12 over 72 plus 0. So 16 plus 12 is 28 over 72. And we can look at the last step. I'm sure you guys are already well versed in the process given right here, and maybe you can try and do it on your own. So basically when y is equal to 2, what we have is h2. This is the notation with respect to x. We have fx2. And now our job is to make sure we keep on changing the values of x accordingly. So first we are going to start with the smallest x, which is 0. So f02, and then we move on to the next x, f12. Finally, the last one is f2. 2. And the values related to that will be 2 over 72 plus 0 plus 0. So the final answer is for y equals to 2. This is the result of hy, which is 2 over 72. And hy right here is what we call the marginal distribution for y. And you have seen that in this case, what we have done is we have separated from what is originally fxy. So you can see that this table here is the combination of x and y, and we have separated those results here into two different tables, which for this one is related to just x, and so this is the marginal distribution for x, and this one is just related to y, and this is what we call the marginal distribution for y. Alright, I think that's all for now. Thank you very much for watching, and I will see you in the next video with example related to marginal density for x and y. Thanks. See you later.